Hello, this is the Tepid Coder. Today I want to go over writing a small application to parse a file. It'll be a good way to review a lot of the concepts that I've went over in the previous videos, and it'll also help me to introduce a new concept, which is dynamic memory allocation. So, the kind of file I want to load, I'm going to call it loadme.txt. It's going to be a bunch of keys and values, so something like coder equals unfused, right? Sky equals blue. Clouds equals gray. Birds equals annoying. Dogs equals bark. Okay. Maybe it's a width of something equals 100. Height of something equals 1.2. Whatever. Percent even. Anyway, it's going to parse these things. In order to do that, we're going to have to load the file. We can go line by line, which would be a really efficient way of doing it. Or we could load the whole thing into a buffer, which is actually what I'm going to do for reasons I'll explain later. You wouldn't want to do it for a large file, but something like this is just a configuration file kind of thing. It's perfectly reasonable. So let's do this. Let's call it parser.segue. What we need is standard input-output, which includes things like printf, fprintf, I don't think that's sinprintf, that'd be in string probably, but it does have things like, loading files, because it's input-output. That includes the console and files. I'll do stdlib, standard library.h. I'm going to do types.h, so I can print out what I'm getting from the file, if I do any kind of integer type thing. I'm going to do standard int.h, so I can use my own cross-platform types here. Well, I'm playing on my own. Standard. I'm going to make a function here called loadFile right off the rip. And what I'm going to return is a char pointer to the contents of the file on success. So I'm going to call it loadFile. And I'm going to say file name. Now, there is a structure type here, or maybe it's not even a structure. Maybe it's just a like a void pointer or something, or an integer. Anyway, it's a handle that you can reference to talk about the file. And you get this handle, let's say, from the operating system. And the way you question the operating system that you get an instance of a file that you can work with is by calling fopen for file open. It'll return this file pointer, whatever this file pointer is. It's kind of opaque to us. Anyway, you want to open the file, giving it the file name, which is going to be file name, whatever I pass, and then RRB for read binary. Okay, and when we're done with it, we need to close it. And before we even continue, we need to see if fn for file input, we're using it for input reading. So, if not file input, if this pointer was returned from here is a 0, then it couldn't be a valid pointer. Memory will never start from 0. So, we're going to say return 0, just like they did. So if they returned a 0 to us with their pointer, the pointer we're supposed to return, which is the contents of the file, is also going to be 0. We couldn't do it because we couldn't load the file. Otherwise, we did manage to load the file, which means we have to close it at some point. It also means we have to return a valid pointer to some character, really a block of them, the whole file, down here. So I'm going to say return, we'll call it lpsc file contents. Okay. So the first thing we need to do is find out how big the file is. So we have to seek to the end of the file to get the offset. So fseek fn, so file pointer, 0, seek end. So from the end of the file, go back 0 bytes. Now there's seek set, and you can set to some position. There's also some, seek cur, I think, CUR for current, and you can put an offset in here from the current. So you can skip around the file. And after we seek to the end, we're eventually going to have to seek back to the beginning so we can read. So fseek fn 0 seek set. So in this case, I'm setting the current position in the file to be 0, the start of the file. Okay. So right here, what we're going to do, we're going to say, don't really need a variable this big, but why not? What am I doing? File size. In fact, this can't be more than 32 with the way I'm reading it. There's ways to read files that are greater than 4 gigabytes, which would use more than a uint32t to reference. However, I'm not using those functions right now. There's like fseek underscore ICT4 or something. They're different for GW and for Microsoft Visual Studio, just the way their libraries work. So I don't want to use those right now. I'm just going to use the basic ones that are consistent across C compilers. So anyway, the file size is currently ftel fn. So tell the offset for the current file we have open here with this file handle. So what's happening? So I'm storing the file size. Okay, then I seek back to the beginning. Then what I'm going to do is I'm going to say I have a character pointer. I'll call it LPSC for long pointer to a null terminated string, got a 0 at the end. File contents equals, we're going to say to file size, but we need, I'm going to word this, we need to allocate memory that is of that size. What I could do is I could say malloc this size. What this will do is it'll actually reserve this many bytes for us and it'll return a pointer to that block of memory. And I actually need to do this +1 so I can have a null terminator at the end. And then what I could do is I could say, you know, LPSC file contents position UIW file size equals 0. So keep in mind that when you have an array, it's always 0 to the size of the array minus 1. But because I added 1 here, the last element is actually this whole file size. So this is ensuring there's a 0 at the end of the file after I load it. What people would usually do is they would be lazy about it and just say calloc. You're going to do size of the element you want, char, and then how many of them do you want, right? You want as many as there are in the file, +1 so I can have a 0 at the end. Now calloc will automatically 0 all of the memory that it allocates for you. So the entire block it's going to give you a pointer to is already going to be 0'd. So that's kind of nice. Even I'll use calloc sometimes. In this case, I'm not going to though, because I don't need the entire block to be 0. If I were going to allocate a structure in memory, I would use calloc because it's going to initialize everything in the structure to 0 for me. I'm not using a structure here, I'm just doing a raw array of elements, so I don't need everything to be 0, I just need the last element here to be 0. So this is going to be a lot quicker. I mean, I say a lot quicker, but I'm doing it once, and it's not really going to matter, it's going to be a trivial difference. Anyway, we need to read the contents of the file into that block of memory, so fread for file read, we're going to say, let's see, how many... I get confused on this if it's the number of elements first or the count first, but it doesn't really matter. What we really have is like size of a character and how many of them we have to load. So UI32 file size. You know, this is also equal to the file length because each character is 1 byte really. So we're assuming it's in ASCII. Okay, I'm going to read that. And what we're reading it into is actually the buffer, LPSC file contents. What we're actually passing here is a char pointer. Actually, it's a void pointer, technically, which means it could be any type, any kind of pointer. And it's probably just going to cast it when it's using it into like a character pointer, some kind of 8-bit integer. So what we're going to read is an element size, let's say, and element count. And it doesn't really matter what the order of this is, to be honest, because it's just going to multiply these two together. Like, what's the size of each element you want? How many of them do you want? The only real implication here is when fread fails, it's going to return something other than the number of elements you asked for. So if you want to test it for failure, you could be testing it to see if the number of elements is equal to what you passed. Let's actually look at that in the documentation. So I'll do fread. Okay, look at the reference. I'll actually bring it over here so you can see it too. So what does it do? It's got the size of each element and the count. So I think I was right. Yep, size of element and the count. Okay, and then what does it say? Reads up to count objects in the buffer. Okay, storing results, blah, blah, blah. I want the return, but here it is. Okay, number of objects returned successfully. So, which may be less than count. If an error or end of file occurs, then the size or count is 0. Okay. Right, so if it reached the end of the file before it filled as many elements as you asked it to read, then the count is going to be less. It's just going to be the number it read. So if the size or count is 0, it just returns 0, which makes sense because it would have read 0 elements. I mean, that kind of goes without stating, but does not distinguish between in-file error, and callers must use FEOF and FERROR to determine what kind of error occurred. I wouldn't really care what kind of error occurred personally. Just knowing that I didn't read all of the data I wanted is kind of enough, but there may be some situations where you care about that. Okay, and I have to say where I'm reading from. I'm reading from the file handle. So I'm going to read the contents into this block that I allocated right here. and this is the pointer to that block. I'm reading elements of type character, which have 1 byte each, and I'm reading, however big the file is, elements. So I'm not reading as far as that +1, where this 0 is. So that means at the end, I'm still going to have that 0. And then I'm going to close the file because I'm done with it. And I'm going to return the pointer to that contents of the file. So, kind of a lot, but none of this should have been really too difficult. So I'm going to say lpsc file contents equals load file. And I called it loadme.txt. Okay. Now, something I need to say, when you allocate something with malloc or calloc, you need to free it. It's not going to happen automatically for you. You need to say free lpsc file contents here. Whatever you called it, you need to free that block memory. If you do free twice on accident, it's going to crash a program. I mean, it can be undefined behavior technically, but the only thing I've ever seen it do is crash. So keep that in mind. You need to free the memory, and you need to free it only once. A lot of times when I'll free things, I'll actually set it to 0. That way I can test it. So like, if lpsc file contents, then free it and set it to 0, right? By doing that, I can say if it's a valid pointer, then free it. That way, if I was careful and I set it to 0, I don't accidentally free it again somewhere else. So that's something you might want to try to do. Okay. Anyway, let's print to stand it out. Here's the file's contents, new line. There's the file, 2 new lines, and let's say lpsc file contents. Okay, so we're going to print out the entire file that we loaded. So parser.cp parser. Alright. So what doesn't it like? Line 19. 19, okay. We have... Oh, right. So this wouldn't matter in C, but in C++, you need to typecast your pointers. The pointers have to have the same type. Malloc and calloc both return the type void. So the void pointer like this. So I need to convert between this to a char pointer, which I'm actually using right here. That's this type. And the way you do that is you cast. So char pointer. I put it in parentheses. So that's how you do that. C++ wants it to be the same type of pointer, that's all. In C, it doesn't care. You can implicitly convert between types. Okay, so that should work. There it is, it loaded it. That's the contents of the file. If I do something like cat loadme.txt, same thing. You can see that's the contents of the file. So now what I want to do is I actually want to start parsing this. I think I might do that in a separate video, because this has gone on for a while. I don't know. Should I? I think I will. Alright, I'm gonna stop here. I'll catch you guys later. Like, comment, and subscribe.